Good morning. This is Santosh Kumar, Assistant Professor in SR University, Mechanical Department. So today we are going to discuss about the important topic in current industrial manufacturing sector, that is comes under like process smart manufacturing. So we'll see in, briefly about overview of smart manufacturing and the definition and key principles and the evolution of manufacturing paradigms. So, before understanding about smart manufacturing, first we'll see what is the need of this. So, during pandemic, most of the industries, not only the automobile sector, most of the various sectors like pharma, even education sector, and many sector industries have lost their employees, they lost the jobs, and due to the lockdown. So, where you can see here, most 48,000 crores expected loss for the especially for government declares that only the particular 21-day lockdowns. Assume that we have faced almost a 1 year shutdown during pandemic. So from here we started to understand even the companies stopped in the futures due to any pandemics. So that should not suffer to the employees as well as the companies. So from that point of view, so most of the industries started to adopt the virtual or smart manufacturing technologies, where with a lesser amount of employees or without physical interaction of the systems, we can also run the factories with the help of these smart manufacturing technologies. So when we see about smart manufacturing technologies, before adopting into the education sector, so we also see so what are the future uh, job roles which have existed or which is going to come in the smart manufacturing technologies. So briefly, we'll see these are the 20 different job roles identified in various job portfolio profiles websites: smart mechatronic engineer, digital factory automation engineer, digital process automation engineer, remote diagnostic maintenance engineer. When we see one by one here, so where the students need to have a understanding of basic mechatronics like electrical, electronics, a background of a coding knowledge, and understanding mechanisms. So the student knows about this, then he will be eligible to apply for these particular roles, especially these roles. So when it comes to the analytics part, where when the machine is running and when the machine is going to fail you or the particular point is going to break down, so during that situations we want to analyze the predictive, like predict the machine failures, we can verify through this predictive maintenance techniques. The engineer can able to understand the bearing components or any other running components in the machine. By understanding the prediction techniques, he can able to give the information to the hierarchy so that the company started to predict procure the particular parts before going to shut down. because when the machine is going to shut down in any industries, it will be a huge loss to the companies. So by considering this, so most of the uh, industries, they are also adopting sensors based mounting on the machines, where the sensors will give the data. So with the data, engineer can analyze and take the decision when the part's going to be failure. Then when it comes to the digital design development engineer and digital quality metrology engineer, digital twin simulation and modeling engineer, all this comes under a quality verification. When the machine are running in the factory, parallelly a quality engineer or PLM engineer, it's a product lifecycle management engineers, should verify the both the quality of the material with the comparing with the physical quality of manufacturing products can be verified at the same time. If any changes are happening in the physical or virtual data, immediately he or she can take the decision, inform to the concerned maintenance engineers to stop the particular machines and go for maintenance action. Another roles like IoT and smart sensor technologist, most of the sensors we have, but it is having different sensitivity levels. When you want to use any particular sensor, it is involved the casting. So based upon the application, what kind of sensor and what is the limitation of the sensors, he or she can able to know, then able to get output from the system with the lesser cost. We get more output of the sensor data. The next thing is the connectivity and communication specialists and virtual and augmented reality and machine learning algorithm developer and smart manufacturing data analyst, dashboard software engineer, cobot application engineer. All this from 10th to 14 comes under majorly when we deal about the connected data, how we are representing to the physical world, that is your on the dashboard of any gadget. If you want to verify the data, how this data is able to uh, uh, going to display in the board and how the data is coming and how we are going to interact with that particular data, all comes under this job roles. Next, cobot application engineer or robot application engineer comes under the advanced automation systems applications, like when the industry there is a new human interaction. If you want to move the materials from another one place to another place, where cobots are going to help you, especially the cobots having the another advantage with the compared to the robot systems, that is AI inbuilt robots. It's called cobots. If the data is coming irregularity or not properly, then it itself take the decision to change its original code and to make it job done. So this kind of development of cobot applications, it is a very high feature in particular smart manufacturing sectors. Then we have cyber data security specialist and OTIT or cyber physical system integration engineer. smart CNC machine designer, additive manufacturing technologist. So all these also comes under smart manufacturing job roles, which help to develop cyber physical systems, which is going to run very smoothly. Generally, we follow this few steps to implement proper smart manufacturing technologies. So that is first one is introduction to smart manufacturing, where we'll understand about importance of smart manufacturing and definitions, applications, and few case study where it's required to understand smart manufacturing technologies. Next stage, we will see the foundations of Industry 4.0 IIoT and digital twin. And so, this digital twins is a generally a replica of your manufacturing product or manufacturing system, where exactly where you can see the product virtually, and you can also automate this system from your systems, maybe a laptop. So with this, you can able to change the parameters. You can control the parameters without going to the factory, and we can also monitor through even normal mobile gadgets. So when it comes to the hierarchy level, like artificial intelligence, when we adopt this AI into manufacturing, most of the times while running in the production system, where we can generally get the data from the sensor. So these sensor data we can also uh, online or the runtime we can analyze, and we can take the decision spontaneously, and this will help the most of the industries to avoid any breakdowns. When we interacting with this physical systems to the network, especially through your laptops or your desktop, which you are sitting in very far from the factory. So we require the help of this internet connection systems, which involved with high speed connectivity. This is a major advantage. It's also the disadvantage, like the cyber attacks. So to avoid this hyper attacks, what kind of IP configurations from the factory and what kind of Ethernet configurations, IOP configurations, and all those things will comes under this cyber security in the smart manufacturing platforms. When you see the definition, smart manufacturing is the integration of advanced information and manufacturing technologies like AI, IoT, robotics, with integration of the cloud and big data. So, to all these generally will be create a flexible, efficient, and data-driven production systems. Here, when we talk about the data-driven, because entire that physical system when we available in the factory as a manually we can verify and we can change those systems operation and controlling can be done through manually. When it's we far away from the physical systems factory, we have only the weapon that is the data. So the data which is generating by sensors, that is only we can have as a parameter where we can able to change the system data and system, uh, maybe physical changes can be done only with the help of this data. So once we want to change any data, so when we give the some command to that, so through your uh, through cyber network, and it goes to your operation configuration like PLC, then it actuate the systems, and through that the component will move. So like that, we can understand this definition. And major key principles are like interconnectivity, like IIoT and cyber production physical systems, and real-time data, that is information transparency, AI agents, this decentralized decision making. Most of this, your microcontrollers having like ESP32, all those things generally comes under the offline based or non-AI based microcontrollers, where the manual feeding is required to the processor. Based upon manual feeding, it started to change this actions based upon the controlling commands. Whereas after adopting AI agents, like decentralized decision makings can be done, even it sometimes the decision is not command is not able to reach to the controller. The pre-inbuilt data which already having that take the decision and it will act accordingly. So that is the major advantage of this decentralization decision making with the help of AI agents. So with this, we need to also adopt the automation and adaptability, the help of robotics and digital twins. The limitations we have in the manufacturing, current conventional manufacturing. I am not talking here smart manufacturing. The conventional manufacturing, which we are following from last 2 to 3 decades. Challenges are low adaptability, means the fixed production lines can't handle the customization easily, a high downtime, the manual maintenance scheduling, unexpected failures, which generally we are facing in most of the industries, and siloed operations, like due to poor communications between different departments. So this is also lagging production, and quality control generally often other than predictive. So after uh, like before damaging any product, we will take immediate action. So with that, we can able to manage the quality of the product and data scarcity, manual data collection and discontinued systems. These are the major uh, issues when we see in conventional manufacturing. What we require now? So real-time need for smart manufacturing. Currently, it's you can see the global supply chain volatility demands dynamic and resilient systems, customer-driven markets, and based upon that, the company should act ready to adopt the flexible manufacturing systems, and for the varieties of production or varieties of products. Sustainability goals require real-time monitoring of resource consumptions. Workforce shortages push to automation AI assistance. As we can see, the after AI adoption into the market, one way is also getting benefited due to lack of manpower. So these robots, especially the comes under automation, it is helping a lot to the manufacturing sectors, especially the any hazardous environment. Uh, Human cannot able to enter. So where we need a physical interaction is required, and due to this scarcity, so robots like machines can easily enter and do the operation in the hazardous or extreme condition environment. It can easily tackle the situations, and sometimes predictive maintenance also reduce the cost and unplanned failures. So, what is the advantage of smart manufacturing? It's flexibility, easy to adapt the production changes, demand fluctuations, and cost efficiency, optimized environment, energy use, and labor. Real time monitoring, the data visibility across supply chain, and process quality and precision quality. Both are very much easily can achievable with the help of AI driven defect detection systems. So when it comes to sustainability, so we can achieve energy efficient machines and digital waste can be reduced. So by adopting this smart manufacturing technologies. So transforming from traditional to smart, it is also involving the many aspects, uh, investment for adopting new technologies like purchasing and trained skilled tech employees. It is also cost involved. However, by observing this advantage, it is also possible by adopting like these five categories. Digital infrastructure can be improved, so such as the sensors and network missions like HMIs and PLCs, and various sensors like temperature, vibration, and motion, and so many sensors based upon the industrial needs and data collection analytics. The data generating through sensor and network machines, it needs to be stored in cloud environment by integrating edge devices with the integration of AI. So this kind of edge computing devices are nowadays available. So these are the generally uh, media between the production system as well as the media between production system to the network configuration which is connected to the M. Another one is automation and robotics, where we can reduce manual dependency. Most of the industries now adopting the robots and AGVs to do these jobs, especially companies like Amazon, like inventory management, they are adopting these kind of technologies. And digital twin adoption, by adopting this, we can simulate the systems and we can predict and we can optimize before bring it to the greenfield projects, and where we can optimize the system to avoid initial stage of shutdowns. And by adopting the standardized cybersecurity norms, we can secure our physical systems like machinery and sensor and edge computing devices with the standard operation procedures. For example, when we consider this, it is a simple a lathe machine, conventional lathe machines, where we can understand the during machining of particular iron rod, and we want to see what the parameter it is changing and what the parameter needs to be controlled. So, when this roughness is increasing during operations. So that directly will detect in your signals or any abnormal misalignment in the lathe machines, that is also can be verified this abnormalities in the signals. So these signals can easily understand by doing signal processing techniques and verify the abnormality comes under which part. Maybe a misalignment, maybe bowing of the particular uh, shaft, or increasing the roughness, or any porosity or blowholes existed in the surface of the machining part. Everything can be easily verified without interacting with without physical interaction with the machines. So this everything can be verified through your dashboards. Assume this currently this image is only uh, connected with the cables. However, when it comes to smart manufacturing, after adopting your DAT to the cloud environment, and the cloud environment having database, and that database, the real-time data directly will fetch into your data acquisition system to the cloud, and through the cloud we have a dashboard like many softwares available in the market, Grafana or Siemens based, or many companies are providing to monitor real-time data of the machines, and we can immediately take the decision of whether to run this machine smoothly or should we stop in particular time, or we can change the parameter, or we can reduce the RPM. Like that we can take the decision and we can optimize the systems. When we see this summary of the discussions as of now, smart manufacturing uses especially AI, artificial intelligence, Internet of Things, and robotics for flexible and efficient and data driven production systems. This we discussed already. Most of the industries in Industry 3.0 technologies, where we don't have this AI and very less amount of IoT we have used. However, we used robotics, but it is not a AI enabled robots. So when it compared to Industry 3 to 4.0, we have adopting this complete AI with integrated with edge computing IoT devices, and easily you can able to run the production systems. The conventional systems, we have seen the limitation of this, lack of adaptability and rely on manual works. And if any issues like pandemic situation comes, this conventional systems will immediately needs to be stopped. And this also offered limited quality controls. Like when you want to see some particular images of 1,000 parts, it is very difficult a single person to verify in a particular time. So now the AI enabled image processing technologies are offering very effective and fast quality checking with high quality precision. Quality control can be achieved. Real time needs like supply chain issues and customization, sustainability, labor gaps easily can be avoided, and key benefits are flexibility and cost saving, precision. real-time insights, and eco-friendly um, materials we can able to produce. And transition needs digital tools like automation, AI, and cybersecurity. Most of the companies already adopted, especially like Tesla, car manufacturing, where we can see an entire digital twin manufacturing of cars are happening, production is happening in these companies and like other companies as well, Honeywell and many more. So this is I discussed here entire need of smart manufacturing and adoption of need for adoption smart manufacturing technologies and lack of conventional manufacturing systems and what is the major advantage when we adopt smart manufacturing technologies. Thank you. In the next class, we'll see some more topics related to smart manufacturing.